So good morning. Thanks for the invitation, first of all. And yeah, so my name is Dariel Téllez. I'm an Additive Manufacturing Research Engineer at Siemens, based in Atlanta, Georgia. I'm going to speak a little bit, and my conference is called From Concept to Reality, a Siemens Additive Journey. So I'm basically going to tell you the story of how we got into additive manufacturing and how we tackle those obstacles that we had along the way and how we have succeeded with it with the equipment that we had at hand and with help of others. So here's a little bit of the contents of this talk. So I'm going to go a little bit of an overview of what EP is, which is the divisions we are in. I'm going to talk about why additive manufacturing, how we started with this, talk about our AM Center in Peachtree Corners, the other AM Centers that we have in EP, talk a little bit about the UL Blue Card program, which is something that we took advantage of, and it's pretty useful for us, or has been pretty useful for us. Talk a little bit of university research that we just started, how are we spreading the word for this, and close everything out at the end. So I'm going to start with a little bit, and bear with me with here. This is not a commercial, but I'm trying to put everything in context. Context of what are we actually getting to with this technology? What are we building, and what are we getting prototypes for? So Siemens is a huge company, right? And it's a worldwide company. We are in the part of industrial business, and we are on the smart infrastructure division. So under the umbrellas of smart infrastructure, there's business units that are covered under this. We are under the electrical products one. So taking this large block of electrical components, we chunk this one in different smaller sections, and we basically tackle problems in different areas of safety, control, and monitor and drive, and divide, I mean. So this is basically the gamut of products that we actually tackle and that we've worked with every day. So I'm just here, again, contextualizing this in order to let you know that we are not using this technology for, just little trinkets or little things for show off, but we are using it for actual equipment, components, and things that goes into safety equipments, and it has a big impact. So a little bit about this. So we are in a $10 billion market. So what's important out of this is in the last 3 years, we doubled the revenue of our division. What this meant was a huge challenge for us. In the R&D area, it meant that we actually needed to iterate faster, right? We normally develop products, and we traditionally been with normal traditional methods, we've worked with the same concept in time. So we have a huge design loop, right? Where design loop, I mean when we get a part or a prototype that is ready to be able to assemble, test, and analyze, normally that whole process takes a long time. And this basically just extends the time of the process from start to finish, and it takes years for us to develop something. So what we did is actually introduce additive manufacturing and start creating smaller loops, like faster ways to test things, analyze things with the right materials, with the right tests to get quicker results and start getting on and faster and faster. So this is something that caught attention for everybody in the company, and that started the motion of this whole movement of additive manufacturing within us. So this is a very generic set of things that are good out about additive manufacturing. So, and they are very well known. Why are we using additive manufacturing? Well, it's a good way to accelerate prototyping, right? We do things faster because we have everything in-house. We can just print it, and the next day have something, assemble, test, and get results, right? Keep going, iterating, and then changing designs. It allows us for customization too. So anything that we can do to move design and do things that we were not able to do before, we do with the technology. It also unifies assemblies. It's very difficult when you think in an industry like ours to do a unified assembly of a safety product that is going into a building and is going to protect the building and an electrical power grid. But in our case, we saw it as, okay, we need to test this equipment with fixtures and with different things that normally we build blocks and we machine everything and we assemble it, and then after assemble, we test parts and do different design verification tests. In this case, we can do all this just in one single print and then just get everything verified and really quickly and faster than before. Part flexibility talks about complex components, and this goes into, again, more into the fixturing that we use for testing. And part reliability is also a big part of it. Once you have your machine tuned and everything is as it should, every part is exactly the same over and over and over. As long as you maintain the machine and everything is tuned again, you'll get the same results. So here's a little bit of a controversial take. And the people from the industry that is hearing right now is probably going to understand this really good. But I just want to just picture this, a concept. So everything can be 3D printed, yes. I mean, whatever you think, like you dream of it, you print it, you have it in your hands, it's very useful. But really, in reality, not everything should be printed, right? You need to make a good case out of this. And I'm going to give a quick concept or example about this. So imagine you have a small part, right? This small part you made by millions, and it costs cents, right? It wouldn't make any sense to change this to a 3D printed technology because it will cost more. And now you will need a fleet of machines to build your million of parts. So in this case, it doesn't make any sense, right? Why will go with this? And what I'm trying to go with this is do not oversell the technology as, yeah, I can do everything. I'm going to remove all the CNCs, all the mills, all the machines that I have because I'm going to get this equipment that can do everything. That's not true. It can do a lot. It can do wonders, and it can help you in a lot of ways. But you need to be very careful on what's the project, if it makes sense or not, and if you're actually, if the part's going to be good for the use case. So this is a little bit of how we started, right? And it's pretty funny because this is just a little small printer that started behind my desk, actually. The first step for everything in life, in work, and everything is the hardest one. So for us, it was a long journey of asking for budget, trying to say, hey, we want to get this cool equipment, but it's very expensive. Can we get budget for it? And the answer was no, because you have not proven anything, and it's very expensive. We don't have time or money for that, right? So we decided to start slow, right, and small. So we just bought a little small machine, put it behind my desk, start asking the engineering teams, hey, do you have prototypes? Do you have different designs that you want to try out? They had some. We started printing them pretty early stages of us knowing how to use the technology, but it worked. So we started printing parts, we started assembling, giving them the parts, they start testing. All of a sudden, months later, everybody started seeing the possibilities we had with this technology and say, hey, if this is what we can do with this little machine, imagine what we can do with bigger machines. So this started helping some of the projects that we had move on and move faster. It got the attention from management. And there was a very big appreciation or acceptance of the technology after showing what it's capable of. After that, we started getting a little bit more equipment, and then we built or we inaugurated our Siemens AM Center in Peachtree Corners. So Peachtree Corners is the office where I'm located. This is the machines we have. Of course, it's nothing like the one we saw yesterday, but we have a bunch of printers. We try to get a little bit of different technologies depending on the use cases or depending on what we need. And basically, my goal is to go and communicate to everybody in the R&D department or in other departments what we have, and get feedback of what they need, so we can actually start building this stronger, get more materials, get more equipment, and start getting this and growing it as we need, right? So after having this, we start doing this road shows, I call them. So I start getting those meetings with the different factories from the division and say, hey, we have this equipment. This is what we can do with it. So do you have something for us? Can we help with something? Doing this made us realize that they actually had equipment too. So this is how a big company normally is disconnected, right? So we don't talk to each other. Everybody does what they need to get their job done, but we don't talk to each other. So after start talking with some factories, start talking with some other locations, we defined what a additive manufacturing center was, which is basically a place where there's equipment of additive manufacturing that had its own dedicated person, and has its own space, right? If it was an isolated printer, a chip printer, and a desk of somebody that it was in manufacturing to create jigs, that's just an isolated case. But if there was a place where there's a room, and in this room there's a person, and they are dedicating time and effort to actually get parts and get this moving, then this was a location that was of interest for us to kind of connect. So having said this, so we found, or we created a North Star strategy to kind of unify our efforts. So we identified 3 different centers, one in Fisher Corners, where I'm at, one here in Monterrey in the Siemens factory, and then one in Bellefontaine, Ohio. These were big enough, have enough equipment, and we have enough variety of equipment that we could actually do a better job on getting requests filled and actually diversify what we had. So with this, we basically try to break barriers and try to prevent silos, because we've been siloing and working alone for a long time. Knowing this, and we started this strategy, and it was pretty easy for us to go about, hey, we have a factory in Texas. What do they need? Oh, do they need an SLA printer? Do we have an SLA printer nearby? Okay, they can use ours. We can give them prototypes. We're the same company, so we work out all the details. Or do they need it there, right? If they need it there, then we work all the business case and everything to actually put it in the place, go and give training if needed, and then get everything going. So this is basically a little bit of what we did to kind of connect each other. And this is just a small North America footprint, right? We have a global, after starting talking with other divisions, we realized there's more printers and centers that we knew, right? There's a whole network of additive manufacturing in Siemens headquarters in Germany, and this just expands all over the world, and we actually are now part of that. So we're trying to get our ways under the whole interdivision, I need to print, how are you gonna get all the bureaucracy out? But it's getting pretty good, and we're helping each other, and now we know what we have. So here's a little bit caveat. I'm gonna jump a little bit so we are building electrical products, right? Our products are not meant just for, we can create parts for just prototyping, right? And form, fit, check, and function. But also, we needed to go the step beyond that. We need to go to see if we can get a little bit of production with this, right? Because at the end of the day, this is great for prototyping, but we also want to be able to get this low volume prints that are very complicated, that we don't have tooling for it, or we need to modify tooling. It will take a long time to do, and just get it faster and get it out of the door. So UL, which is a third-party certification company, is the one that we use for, or that basically certifies our products and makes sure they are safe. So they have a program called the UL Blue Card program. So with this, they basically take the material and check the material against the machine and the parameters, and they certify or they make sure that it's working or against their standards. And with this, we have certified material out of the machine as long as we print with the machine they're saying, with the material they're saying, and with the parameters they're saying. So with this, it gave us a really big edge, because we had these projects where we needed ramp-ups, right, of material, but the tool was going to take, 6 months. So how do we get something going in this 6 months, because we're not going to really do anything. We're just waiting for tooling, right? And after we get the tooling, we need to check if they work or not. So going back with this, we basically found a machine that we had that had a material that was certified by UL. They made the test and everything that we needed. And then after that, we basically put it into the breaker, tell UL, they certify the thing, and start shipping equipment with the printed part just to ramp up the production. So this section, I call it the IAM advantage. It's a little bit of use cases or success stories for us. I'm going to go a little bit of one of my favorites that we work on, and this will show a little bit what we've been doing with this in the industry, or at least in our division. So we have this product, which is a circuit breaker. When we were developing this breaker, normally we get all the design locked in, and everything, and then we start prototyping, right? When we started prototyping with this, we didn't have any of the tools we have right now, so we were going with either molding or rapid prototyping from an outsource, which can be very expensive, sometimes timely, it depends, but it can be very expensive. So the expense comes on the cost of cutting POs, all of the approval processes, and all that, those processes that we have normally in big companies to get materials and parts. So in a period of 11 months, since we started to the point that we can actually prototype something, to the point that we can actually get some results, it took us around 11 months for this. And in 11 months, I'm talking about, this is a 3-pole breaker. So I'm talking about just one pole, just the middle pole, the one that had the mechanism. And it was just one test sequence that we thought it was the hardest one. And we were sure by experience that if it passes that one, then we're going to have minimal problems with the other one. So now, enter additive manufacturing. We got machines in. We start getting better materials. We start getting anything that we needed that was functional enough for this. And then we had another project that was another circuit breaker development. With this one, we actually took, from the time we started, we had everything ready and locked in for start prototyping to the point that we actually had results. It took about 5 months. So that's around a 50% reduction of time, a little bit more than that. So the good story about this is we got results in 5 months, but it was not just one pole because we were able to iterate faster. We basically had the design locked in, printed the parts, checked that everything fit in, start modifying the design and make everything or all the changes that we needed, start early testing and get engineering experiment lots of testing until we got everything done. So, and I'm talking about an electrical component again. I'm talking about a temperature test. I'm talking about endurance tests. I'm talking about short circuit tests. So this equipment and this material in particular experimented a very, very harsh test sequence. And it just withstanded everything. It gave us pretty good results and very good information and helped us move forward with the project. So this was a little bit of like the advantage we had with this equipment in-house. This is another one. This is more of a support that we had with Siemens Energy. So during the pandemic, we know all shortages and everything. So there was no material. There was, this whole shortage on the whole supply chain. They received a call from one of the suppliers saying, hey, they had this indicator, which is, well, I think there you go. Yeah, so they had this indicator, right? This is an indicator for a medium voltage circuit breaker. This basically shows if the breaker is open or closed. It's very important. But they didn't have nylon for it. It was a global shortage. And basically, the supplier called Siemens Energy and said, hey, we cannot supply this material for the next 6 months. We're sorry, there's no material. Do whatever you want, but we can't. So they contacted us. We started doing some tests, research what material it was. It was just simple nylon, but at the same time, we needed to make sure that it can withstand anything that was going through that breaker and tested everything to make sure it will work. So in this case, we selected 2 different materials that we found. We shipped them out to them. They make tests, chose one that was aesthetically better because it has a sticker it needed to actually stick. And with this, we started providing about 100 to 150 pieces per month for production. So this was put in a breaker, and this was shipped out, and this prevent the whole line to actually stop. So this saved millions. This is a little case where it's important to remember the phrase of everything can be 3D but should not be 3D printed. This can be 3D printed. If you make the case right now on that part and say, oh, I want to change that for additive manufacturing, it wouldn't make sense because it's nylon. It's simple nylon. So we pay cents for this. We're building it for probably dollars right now when we printed it. But it doesn't make sense in the use case of using it forever. But in this specific case where we just needed it to solve a problem and to stop a factory line that was going to stop and was going to lose millions just by being stopped, it just makes sense, right? I wasn't trying to scare you away of don't use it. No, I'm just trying to tell you, like, find the right case. This was the right case. Financially, it wouldn't make sense by part-to-part cost, but it does make sense for the application. This is another one going actually on the sustainability route. This is a little bit of experimentation we're trying to do with thermoset recycling. Whoever is in the plastic industry knows thermosets cannot be recycled, and that's it. And we use a lot of thermosets on circuit breakers. It's a great material. We infill it with glass, and this gives us the strength needed to withstand all the certification tests and everything that we need for this. So one thing that we were trying to do is, what if we regrind the material, put it in the virgin material, mold it, in this case, compression mold it, and see if the properties change, right? What if we do this? If the properties and mechanical properties are exactly the same or similar, then yeah, we can probably use it, right? If it's acceptable and our certification accepts it, then we're good, and we're helping the planet, and we're doing everything for sustainability. So what we did here, and this might look simple because I cannot show all the other parts that we did, but this is just a simple dog bone. What I'm showing here is the capacity that we had for go to this concept of, hey, what if we just regrind something and just put it into virgin material and mold it, to, well, I have a printer that can print a mold. Like, you wanna mold out of metal that can withstand 5, 10 tons of pressure and the heat to actually build and mold the part, I can do it. So we got this really quick mold. It took us around probably 1 week just to get it out. They started the process of regrinding a scrap material, putting it in, started mixing different ratios, and they started getting the results of this. So this was preliminary testing that we completed. They are now moving to different actual components right now, proving this theory and see if this way we can remove all this material that would otherwise be on the landfill and then just be there forever, and try to put it back in products that are going to be recycled and still be used by our customers. So here's a little bit of research that we're starting actually with Georgia Tech, or Georgia Technology Institute in Atlanta, Georgia. So we're trying to expand our research capabilities. We know we have a limited set of equipment, and that we don't probably have the space for this. So we reach out to Georgia Tech. Georgia Tech showed us their capabilities and installation. Everything was great, and we started a research project with them. This basically is going to help us further advance the technology, see what we can do with this, and basically grab or combine, as they were saying before, combine academia with industry and see what we can come with. In this case, this is a very specific project that we had, but this is just kickstarting all the whole synergy with industry and universities to kind of move on and keep doing this kind of research. So in this case, we are trying to investigate or research on hybrid technology, which is additive plus extractive at the same time, but for small metal components. So this is something that we are pretty excited about. This is something that we're searching for. And this is, again, just a kickstart. And then we will see what other projects we can do with them, what other projects we can do with Tec de Monterrey, and what we can do together to actually advance this technology further. And so this is a little bit of strategies about spreading the word. Sometimes I feel that I'm the AM marketing person there. I'm just trying to convince people to use the technology, because reality, the more we use it, the more we are gonna advance on it, right? So we started creating some sort of like newsletters with simple bite-sized topics that people with the knowledge or without the knowledge can actually read in 5 minutes, understand something, and spark some interest on this technology. It ranges from, you know, what are the impact, what are the material properties, or which one should I choose, how to create a good STL or anything, from to like what is an FDM printer, what is an SLA printer. This has sparked actually a little bit of interest from the internal people in the company, and they have approached to ask about what we can do with this equipment and how we can help with this. Basically trying to prevent all this fear from this technology, saying, oh, well, that's rocket science, we're not gonna use that. So we're just trying to get away from that concept and say, hey, this is really available, this is here for us. It is actually, in some cases, like in our building, it's in our building. I just go downstairs and it's there. So this has helped us a lot. One other thing is, well, I'm talking about a lot of, you know, technical usage, industrial usage, and very, very hard tests and materials. But there's also like non-technical groups that can use this for very big advantages. Right there in the picture, there's one of our e-mobility products or solutions for e-car chargers. They had a render of the part, and they were going to different conferences and congresses and trade shows, and they were showing a screen with a 3D model, and they was just retaining them and then showing what the capabilities was. And at some point, we just approached and like, hey, can we just print that? Like, you can have something on a table that people can actually look around, see, and feel what it will look like, and have the concept of scale of it. So yeah, this helped us promote new products. We also approach with product management, with all their new ideas, with all the new concepts. And because we normally create 3D models for that. And 3D models, again, it's just something in a screen. So what if we can just print a part? It doesn't need to be fully functional. It can be a mock-up with just the right dimensions to just show it and have the people touch, feel it, and actually know what side. Hey, we don't like the handle on this side, we like it on this side. Oh, but that's easy. You just move it away, right? It's just a mock-up. So this is a way we have found to actually promote products, to promote concepts, ideas, even promotional items. Like, all those things are pretty eye-catching, and they normally spark interest of, hey, how do you get this done? And that's how the conversation starts. And this is, to close it up, we've been driving a lot of impact with this. We've made process more efficient. We've looked forward towards sustainability. There's a big thing I want to get through today that I really want you to get home and think about. Not too hard, you need to really sleep. But we're finding new and innovative ways to use this technology, right? We're trying to get this going. We're trying to get people to use it. We're trying to get people to find how good the technology is right now. Technology has been advancing crazy in the last years. So it's been going super fast, actually. If people that have used this technology in the past 2 years know that a machine 2 years ago is totally different than a machine right now. They're faster, they're better. There is material science going in very hard and strongly. There's new application going for it. So what I'm just trying to say is, the more we use the technology, the more we adopt it, and the more we demand applications for it. We will demand new materials. We will demand new blends of plastics, new powders of metal. Anything that we need in the industry, this industry will keep growing, and will actually continue moving forward in the right path as it's going right now. So make sure you make a conscious thought of, how can I use this technology for my advantage? Because whenever you start using it, you start having needs, and then there's companies out there that are looking for those needs to get new products, new equipment, and new materials to help us through. So we're basically going to have newer and better solutions if we keep using this technology. And that's everything I have.
Thank you very much. So we're going to pass to the question and answer session. So please, if someone have a question here, or the virtual audience, could you please pass me the telephone? So we are going to have some questions from the people that is following our conference through the platform. So please, if you have any question here, please raise your hand. Okay, Dr. Molina.
I can imagine that you are just playing. You know, Siemens is a very large company. So how you are getting the most of working together, you know, in the different regions of Siemens? Because I believe that the infrastructure that you have of 3D printing is huge. Not only the 3 sections labs you presented, but how you get the most of it, or because the different facilities or different manufacturing capacities you have around the world, they need something completely different from one to the other. So I think that's a huge challenge for you, right?
Yes, that's actually a big thing that we face. What we do is basically we get involved in any projects that they have. We have monthly meetings with the whole AM global team. Basically, they show what they have. We also have some internal SharePoints in places where they have actually the machines they have listed. And we are in the same, or in the agreement that if they actually have an equipment, we can go and ask for parts, for prototypes, or for anything, and be open about it, right? We move away, or are trying to move away from the whole, oh yeah, but you're another division. You need a intercompany transfer, and then you need to talk to finance, and then purchase, and then that doesn't work. I mean, we're a very globalized world right now, and we really need to move away from that. So whenever we need something, and hey, you have a technology and a material that we would like to try, we basically request samples, we get samples, try it out. If there's a bigger, hey, I need 1,000 parts a month, then we're talking a different thing. But just the communication, we're trying to open all those channels to kind of make sure that all those barriers that we normally think when we're thinking of talking to another intercompany section, just remove all those barriers and just have direct contacts. We have all direct contact with us. So like for example, if here in Monterrey, if Franco needs something, he just send me an email and hey, you have this machine, can you send me some parts? Sure, just get it printed, send it here to Mexico, and then they'll just use it, right? So basically trying to break barriers and trying to make the process easier for us. Mm-hmm.
Thank you very much, Roberto.
Well, excellent talk, Daniel, really impressive, very nice. I like the concept that you place about the breaking the fear of the technology. And for that, I don't know, you have any recommendation about showrooms, or how can you get into people? Because sometimes it is a big refrain of applying anything because you fear that changing is difficult. That is normally what happens with people. But what do you suggest to break this barrier?
So, and thanks for the question. So if it's an industry with this trying out, so we're talking about big industries, big companies, right? Trade shows and all sorts of different conferences about additive manufacturing can help you understand what's going on, what's coming out, and what you can do with this. There's one in particular that I like a lot. It's called Additive Manufacturing Users Group. And this is not a commercial, but I just love that place. It's one conference that is every year in Chicago, and they basically bring all the innovation, and there's no external people. They're just industry people. So if you're a company that are trying to search for new concepts or new ways to use this technology, that's the place for it. So all these trade shows, everybody is trying to show what they can do with their equipment. And what I like about this one is these are not salespeople. These are all the research people, all the engineers, everybody involved in the actual design of the machine that can give you all the details that you want about materials, about each of the components inside. And they are not going to be able to, they actually have a penalty if they try to sell you something. So they're basically trying to give you solutions. And they're as good as if you ask for, hey, I need this part, and this is my application, they will go, oh, you know what, I don't have it, but that's my competitor. Those guys have it. You can go over there. So it's a big community. So basically community events and all sorts of this trade shows or different events where you can see what the actual technology is. It's very different to get parts, read articles and see what they can do, to actually hold parts and say, oh, wow, this is the material that you can give me. And there's some tests where they try to break it. This is the strongest steel aluminum, and you just can't break it, right? And you can find the application there in your industry. So I guess those are the best ways to do it. Internally, again, I cannot take the whole company to a trade show and say, hey, just go wild and see what there's here. So internally, more communication about what the technology can do, more of understanding, okay, this is not rocket science. This is something that is applied technology that can help you with something. If you're a technical person, if you're a non-technical person, it's exactly the same. It can help you some way. So.
Thank you very much. I think we have time for one more question.
Thank you very much for your wonderful talk. I really enjoyed. Could you please mention to the general public, because you were mentioning about sustainability of this technology, how Siemens is evaluating the impact of sustainability regarding to the usage of this technology?
Not exactly with this technology. We have an overall program where we need to be net carbon zero by, I don't know, 10 years or something like that. But, so we have different strategies. We are using this technology to complement this. Now, having said that, not having to build a mold for prototype, get 300 parts, and then realize that we needed to change a little thing, modify the tool, and then throw away 300 parts. That's working towards sustainability right now. So we are trying to reduce the waste we're putting on the landfill in this way. So we just produce what we need, we test it, and then we keep going. We never produce more than we need, as we were doing before, again, with molds. With molds, you cannot just go and ask for, oh, build a mold, take 6 months on it, and give me 10 parts, because the molder is going to be like, nah, that doesn't work. So not directly, we're not measuring directly additive manufacturing, but we are using it towards the same goal of net zero, which is a common goal, I guess, in the industry and the world right now.
So thank you very much. So I would like to thank Dariel for this excellent presentation. Really, it's an honor for us to have you here, Dariel.
Thank you.
And let's welcome and say thank you to Dariel.
Thank you. Also, is still on? Yeah. Also, I'll be around, so if you have any other questions or anything, I'm open to answer anything. So if you see me around, just stop by and ask me whatever you need. Thank you very much.
Thank you for coming.